my name is Shivani. I'm one of the new Wyzant tutors, and I'm here to help you with the chemistry problem. So it looks like it's an ideal gas law problem, and let's read it first. We have a 7-liter tank at 7.66 degrees Celsius filled with 4.90 grams of dinitrogen monoxide, or N2O, and 4.66 grams of chlorine pentafluoride, or ClF5. And we can assume that both of them behave as ideal gases in these conditions. So the question is asking us to calculate the mole fraction and partial pressure of each gas, as well as the total pressure in the tank. And we can round the answers to 3 significant figures. So let's go back to the ideal gas law here. So we have PV is equal to nRT, where P is the pressure, V is the volume, and N is the moles of gas, R is the gas constant. So in this case, let's use 0.08206 liters times ATM over Kelvin times mole. So with this gas constant, our pressure that we calculate is going to be in ATM, or atmospheres. T is the temperature in Kelvin. So we need to make some conversions. First, we need to convert this temperature of 7.66 degrees Celsius to Kelvin. So 7.66 degrees Celsius to Kelvin. So we add 273. So every time we go from Celsius to Kelvin, we just add 273 to this numerical value of the Celsius. So it would be 7.66 plus 273. And we would get 280.66. 280.66 Kelvin. So next, we need to convert the masses of each of these gaseous particles into moles. So we would need to calculate the molar mass of each gas. So for the dinitrogen monoxide, or N2O, so it would be 2 times the molar mass of nitrogen plus 1 times the molar mass of oxygen. So it'd be 2 times 14.01, and it's in grams per mole, plus 1 times 16.00. It would be 44.02 grams per mole. Molar mass of the chlorine pentafluoride would be 1 times the molar mass of the chlorine plus 5 times the molar mass of the fluorine, which would be 1 times 35.45. Let me just double check that real quick. So yeah, 1 times 35.45 for the chlorine, and let me look up the molar mass of the fluorine here real quick. And the fluorine is 19.00. So it would be 130.45. All right, so now that we have the molar masses, we can convert the grams of each gas into moles. So we have 4.90 grams of N2O. Now the moles, let me use a different color here. Let me use red. The moles of N2O is equal to the grams in the grams of N2O divided by the molar mass of N2O. So this would be 4.90 grams divided by 44.02. And I'm actually going to show it this way, just so that you can see the units cancel out. So it's going to be 4.90 grams times 1 mole over 44.02. So it's the same thing. You have the grams divided by 44.02, the molar mass. I just want to show you how the units cancel out so that you end up with moles. So notice how grams and grams cancel out. You're left with the moles as the units in your answer here. So let's plug this into our calculator. So you would get 0.1113 moles of N2O. And now we can calculate the moles of the ClF5 in a similar manner. So we have 4.66 grams. And again, notice how the units of grams and grams cancel out. So your final answer has the unit of moles. And when we plug this into the calculator, we get 0.0357 moles. Let me just mark these down on my paper real quick. All right, so we calculated the moles of each gas, and we also have the temperature right now. So we are ready to, let's first calculate the mole fraction of each gas. So from our previous problem, we had 0.1113 moles of the N2O, and we had 0.0357 moles of the ClF5. So the total number of moles in the mixture is simply going to be the sum of the moles of each of the gases, which would be 0.1113 plus 0.0357, which would be 0.147 moles in total. So now the mole fraction of N2O is going to be a decimal, and it's going to be the moles of N2O divided by the total number of moles, which will be 0.1113 moles N2O divided by 0.147. It would be 0.757. And the mole fraction of ClF5 is calculated the same way, but with the moles of ClF5. All right, so I ended up with 0.757 for the mole fraction of N2O and 0.243 for the mole fraction of ClF5. Now, a key thing is the mole fractions of all the gases must add up to 1. So we could just do a quick spot check to make sure that these two mole fractions add up to 1. And I just plugged into my calculator and they do. So let me just mark the final answer here. The mole fraction of N2O was 0.757. The mole fraction of the ClF5 was 0.243. So that is how we calculated the mole fraction. So let's go ahead and calculate the partial pressure of each gas. Now, the partial pressure of each gas can be calculated by using PV is equal to nRT for each of the two gases. So given that PV is equal to nRT, we can rearrange the equation for P to obtain an expression for P, which is going to be the pressure of the gas. P is equal to nRT over V. So let's calculate the pressure of the N2O first. So PN2O is equal to the moles of N2O times R times T divided by V. Now, if we recall the values, the moles of N2O was 0.1113 moles. R is 0.08206. Let me just double check that value. And the units are liters times atmospheres over moles times kelvins. And the temperature was 280.66. And the volume is the volume of the container, which is 7.00 liters. Now, I want you to pay attention to how the units cancel out in this case. So moles here cancels out with the moles in the denominator of this constant. Liters in the constant will cancel out with liters at the denominator. And then Kelvin and Kelvin cancel out. So our final answer in this case comes to, let's see. So our final answer comes to 0.366 atmospheres. And we can calculate the partial pressure of the chlorine pentafluoride in a similar way. So it's equal to the moles of ClF5 times R times T over V, which is 0.0357 moles times 0.08206 liters times ATM over moles times Kelvin times 280.66 Kelvin over 7.00 liters. And let's plug this into our calculator. So I ended up with 0.117 atmospheres. And that's rounded to 3 significant figures in both cases. Let me just quickly double check my answers to both of these. All right, perfect. So our final answers in this case, the partial pressure of NO2 was found to be 0.366 atmospheres. The partial pressure of the ClF5 was 0.117 atmospheres. Now the total pressure is going to be pretty simple. It's simply the sum of the partial pressures of each gas. So total pressure is the partial pressure of N2O plus the partial pressure of ClF5, and that would be 0.36 atmospheres plus 0.117. or 0.117 atmospheres. So it would be 0.483 atmospheres. All right, so that's pretty much all the answers with the explanations. Now, before I wrap up this lesson, I just wanted to point out one quick thing. So going back to the mole fractions here of the N2O and the ClF5. So we can kind of check our answer for the partial pressures and the total pressure by making sure that the partial pressure fraction for each gas is equal to the mole fraction. So I'm just gonna write that separately at the side here. So the pressure fraction of N2O would be the partial pressure N2O divided by the total pressure, which would be 0.366 atmospheres divided by 0.483. So that would be 0.757 or 0.758 if you round it up, but it's a small difference and it doesn't really matter. And the pressure fraction of ClF5 is equal to the partial pressure of ClF5 divided by total pressure. So yeah, so a good rule of thumb to keep in mind is that the mole fraction always equals the partial pressure fraction. All right, so that pretty much wraps up this lesson with the answers and all the explanations. If you have any questions, feel free to leave a comment in the comment section, and I hope this helps. Thank you and have a wonderful day.